Welcome to Unit 2, where we will know about the ancient Greek of programming and break down the DNA of C Sharp into something you can use to create games. So these are the topics we are going to discuss in this video. We'll discuss about variables. Variables. Think of variables as the basic labels in your kitchen, where you are cooking. You reach out for sugar or salt. In programming, variables are similar labels, but instead of food ingredients, they hold piece of information. These could be numbers like the score in a game or words like the player's name. And we'll discuss about methods. Now imagine a recipe. It's a set of instructions to create a dish. In C Sharp, a method is like a recipe. It's a collection of statements that together perform a task. When you want to make pancakes, you follow a make pancake recipe. Similarly, when you want your game character to jump, you call a jump method. We'll also discuss about class and objects. Think about a cookbook. A cookbook contains recipes of dishes. Similarly, a class is like a cookbook for objects. It defines what they can do and what information they hold. When you make a chocolate cake object from a cake class, it's like using the cake recipe from your cookbook to make a actual chocolate cake. Uh, we'll also discuss about C Sharp scripts as Unity components. In Unity, components like the ingredients, appliances in your kitchen that you use to make a dish. C Sharp scripts can be attached to the game objects as components that define behavior. Just as a blender mixes ingredients, a script might mix variables and methods to control a character's movement. And we'll also discuss about dot notation. When you're cooking, you need to use the blender's speed settings. You're accessing a specific feature of the blender. In programming, you want to access a variable or call a method from a class, you use dot notation. It's like saying, hey blender, I want to use your speed settings to mix these ingredients. So as we progress through this unit, we'll be connecting these concepts with the practical examples and everyday analogies to help you make sense of it all. By the end, you'll not just know what the building blocks are. You'll see how they come together to form the programs you interact with every day, including the games you love. So let's get started. So the first topic is variables. Think of variables as the atoms of programming. Just as atoms are the basic building blocks of matter, variables are the fundamental units that make up a program. They are the starting point, the essential ingredients without which a program simply can't exist. So now let's get technical for a moment. A variable is a small piece in your computer's memory where a value is stored, like a physical box with a label. Each variable has a memory address, a type indicating what kind of data it holds, such as numbers, words, or even lists, and the actual value itself. Practically speaking, a variable is like a container. You can make as many as you need, fill them up, move them around, swap their contents, refer to them whenever necessary. They're like mailboxes in the physical world. Speaking of mailboxes, picture a row of them. They can hold various items like letters, bills, or postcards. What's inside can change, but the mailbox always has a label like apartment 2B, giving us the context about what it contains and whom it belongs to. Just as you need to know which mailbox to open, each variable in your program needs a unique name. Like names like this name give you a way to access the value the variable holds. So when you set up a variable, you're creating a placeholder for information. So let's take a simple math equation. So 2 plus 9 is 11. Now let's turn the number 9 into variable. Int my variable is equal to 9. With this, my variable becomes a stand-in for the number 9. We can then use it like this: 2 plus my variable is equal to 11. And yes, there are rules about naming and using variables, which we'll explore in detail in the upcoming videos. Even though we are not diving into real C Sharp code just yet, understanding the role of variables as placeholders is important. Soon you'll be declaring and using variables in Unity to start crafting your game's logic. Now let's go to Unity. Let's open the learning curve. So ignore the logic of this program and the comments. Just focus on line number 7. Uh, we declare public int current age is equal to 12. So let's save it. We also write some code to add current age plus 1 and 30 plus 1 in the start method. So let's not discuss about this syntax. Just focus on initializing the variable. So let's go back to Unity. So this line of code creates a variable named current age and assign it a value of 30. It's like saying, hey, we have a character who's 30 years old. So that's so now let's drag and drop the learning curve script. Sorry. Let's drag and drop a learning curve script onto main camera. So when you click on the main camera, make sure that the learning curve script appears in the inspector panel as a component. Now let's hit play button and watch console panel for output. You see the result of simple math operation we wrote using our variable. If you have set everything correctly, the console will show the number 31, the result of adding 1 to our current age variable. So now let's see the magic of variables in action by changing their values on the fly. So click the play again to stop the game if it's still running. In the inspector panel, change the current age to 18. Now run the scene once more and check the console. So the first output is still 31, showing the original value we set in the script, but the second output should now be, as you can see, it's 19, reflecting the change we made in the inspector. This exercise wasn't about learning all about variable syntax. Instead, it was to demonstrate how variables are containers for values that we can set once and use whenever we need them in our code. Now let's understand about methods. So think of methods as the action sequence in a movie. Variables are the characters standing ready, but methods are what we get them moving, fighting and interacting. In programming, method and function are often used interchangeably, but in C sharp, which is object oriented, we'll stick with method. So whenever you come across function documentation, just think method. Conceptually, methods are the workhorses of an application. They do the heavy lifting, and technically a method is a segment of code that executes a set of instructions. When called upon, it can accept inputs known as arguments or parameters and use them to perform its tasks. Practically, a method is like a kitchen appliance. You have a blender, which is a method, and you can put various ingredients, which are variables, into it to blend a smoothie. The smoothie is the result of executing the method. So imagine you need to add two numbers repeatedly throughout your game. You could write the addition over and over, but that's like manually blending each smoothie ingredient instead of using the blender. So instead you create a method. So let's go back to Visual Studio. I have already created the method. So our method name is compute age. We are just calling here, and so we are in this program. We are adding the current age to add age. We initialized current age as 30 and add age as 1. Let's save it. So with the compute age method defined, you just call this method and it handles the addition of for you. So no matter where in the code you are, it's the placeholder for an action. Let's go back to Unity and see, as you can see the output. So Try changing the values of the variables in the Unity inspector and see how the method adapts. It's a powerful demonstration of how methods interact with variables to perform actions dynamically. Uh, so that's the end on methods. They're not just placeholders for values, but for entire sequence of actions. But next, we'll explore the concept of classes and how they organize our code into objects that can be manipulated in the virtual space of our games. Let's go back. So, what are classes? Think of class as a master container which holds all the related information and actions needed to define and control an aspect of your game. Imagine a class as a toolbox. Each tool, each tool is method. So inside it has a specific function, and each compartment, which is a variable, holds different screws, nails, or bolts. A class combines these tools and compartments to work together seamlessly. uh, Technically, a class is a complex data structure. It's the skeleton where you attach the muscles. Muscles are methods, and organs are variables. It's the framework that supports the creation of objects, which are instances of class. In the real world, a blueprint outlines this design of something before it's made, like a house or a machine. In C sharp, a class is the blueprint of for objects. It dictates how they are built, how they function, and how they contain. Uh, Now, every script you've been working on in Unity, that's a class. When you look up at the when you look at the top of the your learning curve script, see the class keyword. That's C sharp telling you, hey, everything inside these brackets is it's the part of learning curve class. And in Unity, MonoBehaviour is a special one. It's what allows your scripts to interact with the Unity engine. When your script starts with public class learning curve mono behavior, you're creating a class that can be attached to any game object in your scene, empowering you to with the ability to control and animate your game world. Uh, Now let's take the post office example. Let's take the post office as an example. It has a specific address, a variable, and the services like sending and receiving mails. So when another class needs to send a letter, it doesn't need to know how the post office works internally. It just calls send mail, and it works. So when you want to access a specific property or method of a class, you use the dot notation. So let's post office dot send mail. they, it's like saying, hey, post office class, do the send mail action. So that's so with that, you have got the basics of classes down. They're not just theoretically structures, but practical, powerful tools that you'll use to build the structures of your game. uh, and Next topic is comments. So have you ever jotted down a quick note to remind yourself what a complex paragraph in a book means? Code comments are those notes in the programming of in the world of programming. They help you and others understand what's happening to your code, but the computer ignores them without running your program. Uh, so as you can see, two slashes is called single comments. Anything you write after these two slashes uh, on that line won't be executed as a code. It's just for you and the humans reading the script. And sometimes you need a bit more space to explain things. That's where multi-line comments come in. They start with a slash and an asterisk, and ends with a asterisk and a slash. So that's what it looks. So some might say the comments aren't necessary, but I firmly believe they're one of the most important habits you can develop as a programmer. You need your code clean, understandable, and maintainable. So the next topic is scripts as components in Unity. Uh, so when you drag and drop a script onto a game object, like we did with the main camera, the script becomes a component of that object. You can see this in our inspector panel. The script, now component behaves just like any other component in Unity. It has its variables, methods, and that can be interacted with and modified. Uh, Unity automatically formats script names and variables for better readability. So Unity's inspector panel is a powerful tool. It allows you to modify public variables of a script in real time. Uh, in play mode, changes to variables are immediate but temporary. They are great for testing, but will be reset once you exit play mode. But when it comes to development mode, changes are permanent. Unity saves these changes and they persist across sessions. So understanding how Unity treats scripts as components and the flexibility of modifying variables in real time or in development mode is crucial. It adds a layer of dynamism to your game development process, allowing you to fine tune gameplay and behaviors on the fly. As we conclude this unit, remember that building blocks of programming, variables, methods, classes are now tools in your toolkit. In the next unit, you will go deeper into how these elements come together in Unity to create an interactive and engaging game experiences. So before we conclude this video, we have a last topic: MonoBehaviour. MonoBehaviour is more than just a class. It's the key to making scripts work as components in Unity. Every script you write in Unity, like the learning curve, is a class, but not every class automatically becomes a component. This is where MonoBehaviour comes into play. Uh, so when you see, learning curve, MonoBehaviour at the top of your script, it means that learning curve is inheriting from the MonoBehaviour class. This inheritance is like getting a special pass that tells Unity, hey, this script can be a component on an object. So think of MonoBehaviour as a generous parent class that shares its features with your script, making it ready for action in Unity environment. So the two methods you'll see often are start method and update method. They are borrowed from MonoBehaviour. Start method is like the starting point of your program. It's called once when the scene begins, and update on the other hand is the heartbeat of your script, running once every frame, keeping the script's action moving along with the game. So dive into Unity's scripting uh, API and look up start and update methods, understand their roles and how they function in the grand scheme of your game. If you're up for the challenge, explore the MonoBehaviour class in the Unity documentation. It's a goldmine of information on how scripts interact with Unity. So there's one more critical concept to grasp: how classes communicate with each other. This is where the real power of programming comes into play, allowing different parts of your game to interact and create a cohesive experience. So so far we have looked at classes as individual units, like isolated islands, but in the vast ocean of programming, these islands are often interconnected by bridges. That's class communication. Remember our post office example? We used period or dot to access it address and services. This is known as dot notation, uh, a crucial tool in programming. It's like using a directory to find a specific information. So post office dot address, this line of code is saying, hey, go to the post office class and tell me what the address is. So dot notation becomes even more powerful when it comes to invoking methods of other classes. If the post office class has a method called deliver mail, we call it like this, post office dot deliver mail. So with this line, you are instructing the program to execute deliver mail method within the post office class. It's like making a phone call to the post office to carry out a specific action. So think of dot notation as the lifeline of programming. It's the bloodstream carrying instructions and information where they need to go. It might seem a bit abstract now. As you work more with code, you'll see how essential and important it is. Um, So it's important to start familiarizing yourself with these concepts now. They are the foundation of object-oriented programming and are important in creating complex and dynamic games. Don't worry if it doesn't all click into place immediately. It's like new language. Like any new language, programming takes time to become fluent. Let's take some time to reflect on the ground we have covered and the solid foundation we laid on for our journey in game development with Unity and C Sharp. We started with variables, the basic units of storage and programming, like the mailboxes holding letters. Variables hold data that we use throughout our code. Then we discussed about methods, the instructions or recipes that tells our program how to act. They are the steps that brings functionality and life to our game. And then we moved to classes, the blueprints that define how objects in our game are structured and behave. These are like the architectural plans outlining the design and functionality of each component in our game world. We also discussed about MonoBehaviour, understanding how it allows our script to integrate seamlessly as components in Unity. And finally, we looked at how classes communicate with each other using dot notation, a fundamental aspect of creating interactive and dynamic games. As we move forward, the rest of this playlist will guide you through a detailed exploration of C Sharp syntax. We'll dive into how to create and manage variables, understanding value types, and develop both simple and complex methods. The upcoming units are designed to build on what we have learned, slowly adding layers of complexity and practical application in Unity. Uh, the journey of learning to code is like constructing a building. Every concept, every line of code adds another brick to the to the structure. With the foundation set, we are ready to start building upwards, turning your game ideas into reality. Thanks for joining me in this unit. Remember, practice makes perfect, so keep experimenting with what we have learned. Stay tuned for more in-depth exploration in our next unit. Don't forget to like, subscribe, and leave your thoughts in the comments. See you soon in the next video.